Sodium thiosulphate, also spelled sodium thiosulphate, is an inorganic compound that is typically available as the pentahydrate, Na2S2035H2O. The solid is an efflorescent crystalline substance that dissolves well in water. It is also called sodium hyposulphite or hypo. It is on the World Health Organization's list of essential medicines, the most important medications needed in a basic health system. Medical uses. It has been used as treatment of calciphylaxis in hemodialysis people with end-stage kidney disease. There is apparently an incompletely understood phenomenon whereby this causes severe metabolic acidosis in some patients. It is used as an antidote to cyanide poisoning. Thiosulfate serves as a sulfur donor for the conversion of cyanide to thiocyanate, catalyzed by the enzyme rhodanase. It is used in the management of extravasations during chemotherapy. Sodium thiosulphate prevents alkylation and tissue destruction by providing a substrate for the alkylating agents that have invaded the subcutaneous tissues. The dose may be 2 ml of 0.17 m. It may be instilled subcutaneously into multiple sites using a small gauge needle. Data are limited on this method with few recommendations. In foot baths for prophylaxis of ringworm, and as a topical antifungal agent for tinea versicolor. In measuring the volume of extracellular body fluid and the renal glomerular filtration rate. Other uses. Iodometry and analytical chemistry. The most important use comes because the thiosulphate anion reacts stoichiometrically with iodine in aqueous solution, reducing it to iodide as it is oxidized to tetrathionate. 2s2032- plus I2s4062- plus 2I- due to the quantitative nature of this reaction, as well as because Na2S2035H2O has an excellent shelf life. It is used as a tetrant in iodometry. Na2S2035H2O is also a component of iodine clock experiments. It is also used in estimating volumetrically the concentrations of certain compounds in solution and in estimating the chlorine content in commercial bleaching powder and water. Photographic processing silver halides, e.g., AGBR, typical components of photographic emulsions, dissolve upon treatment with aqueous thiosulphate. 2s2032- plus AGBR, Ag2, 3- plus Br-. This application as a photographic fixer was discovered by John Herschel. It is used for both film and photographic paper processing. The sodium thiosulphate is known as a photographic fixer, and is often referred to as hypo, from the original chemical name, hyposulfite of soda. Gold extraction. Sodium thiosulphate is a component of an alternative lixiviant to cyanide for extraction of gold. However, it forms a strong soluble complex with gold ions, O2, 3-. The advantage of this approach is that thiosulphate is essentially not toxic in that ore types that are refractory to gold cyanidation can be leached by thiosulphate. Some problems with this alternative process include the high consumption of thiosulphate, and the lack of a suitable recovery technique, since O2, 3- does not adsorb to activated carbon, which is the standard technique used in gold cyanidation to separate the gold complex from the ore slurry. Neutralizing bleach, chlorinated water, and related treatments. It is used to dechlorinate tap water, including lowering chlorine levels for use in aquaria and swimming pools and spas, and within water treatment plants to treat settled backwash water prior to release into rivers. The reduction reaction is analogous to the iodine reduction reaction. In pH testing of bleach substances, sodium thiosulphate neutralizes the color-removing effects of bleach and allows one to test the pH of bleach solutions with liquid indicators. The relevant reaction is akin to the iodine reaction. Thiosulphate reduces the hypochlorite and in so doing becomes oxidized to sulfate. The complete reaction is 4-NaClO plus Na2S2O3 plus 2NaOH4 NaCl plus 2Na2SO4 plus H2O. Similarly, sodium thiosulphate reacts with bromine, removing the free bromine from solution. Solutions of sodium thiosulphate are commonly used as a precaution in chemistry laboratories when working with bromine and for the safe disposal of bromine, iodine, or other strong oxidizers. Other sodium thiosulphate is also used as a component in hand warmers and other chemical heating pads that produce heat by exothermic crystallization of a supercooled solution. In bacteriological water assessment, as it promotes the survival of coliform organisms by neutralizing residual chlorine. In the tanning of leather, to demonstrate the concept of supercooling in physics classes, sodium thiosulphate, when heated, dissolves in its own water of crystallization. This solution can be cooled to room temperature without recrystallization. When crystallization is induced by the addition of a small seed crystal, the sudden temperature rise can be experienced by touch, as part of patina recipes for copper alloys, often used in pharmaceutical preparations as an anionic surfactant to aid in dispersion. Structure. Two polymorphs are known of the pentahydrate. The anhydrous salt exists in several polymorphs. In the solid state, the thiosulphate anion is tetrahedral in shape and is notionally derived by replacing one of the oxygen atoms by a sulfur atom in a sulfate anion. The SS distance indicates a single bond, implying that the terminal sulfur bears significant negative charge and the SO interactions have more double bond character. Production. On an industrial scale, sodium thiosulphate is produced chiefly from liquid waste products of sodium sulfide or sulfur dye manufacture. In the laboratory, this salt can be prepared by heating an aqueous solution of sodium sulfite with sulfur or by boiling aqueous sodium hydroxide and sulfur according to this equation. 6NaOH plus 4S2 Na2S plus Na2S2O3 plus 3H2O. Principal reactions. Upon heating to 300 degrees Celsius, it decomposes to sodium sulfate and sodium polysulfide. 4 Na2S2O3 3 Na2SO4 plus Na2S5 thiosulphate salts characteristically decompose upon treatment with acids. Initial protonation occurs at sulfur. When the protonation is conducted in diethyl ether at -78 degrees Celsius, H2S2O3 can be obtained. It is a somewhat strong acid with pKa's of 0.6 and 1.7 for the first and second dissociations, respectively. Under normal conditions, acidification of solutions of this salt excess with even dilute acids results in complete decomposition to sulfur, sulfur dioxide, and water. Na2S2O3 plus 2 hydrogen chloride 2 NaCl plus S plus SO2 plus H2O. This reaction is known as a clot reaction, because when the sulfur reaches a certain concentration, the solution turns from colorless to a pale yellow. This reaction has been employed to generate colloidal sulfur. This process is used to demonstrate the concept of reaction rate in chemistry classes. Aluminium cation reaction. Sodium thiosulphate is also used in analytical chemistry. It can, when heated with a sample containing aluminium cations, produce a white precipitate. 2Al3 plus 3S2O3 2 minus plus 3H2O3 SO2 plus 3S plus 2Al3. Organic chemistry. Alkylation of sodium thiosulphate gives S-alkyl thiosulfonates, which are called Bunter salts. This reaction is employed in one synthesis of the industrial reagent thioglycolic acid.